I would say that the guiding principles of our tracker and our company are engineered simplicity leading to long-term reliability. And I think we're just seeing the beginning of what we can do with tracking and solar technology.
This is EnergyCast, and I'm Jay Dowen Howard. Today we're talking about solar tracking systems, getting the most out of this renewable energy resource. It would seem fairly simple. Place some solar panels on a motorized hinge that moves with the sun, so it's always getting the most light. That seems simple enough, but then you start to look at all the variables. So what if the sun is low? What if it casts a shadow on other panels? What if some rows of panels are at a different elevation? Or what if it snows or is constantly cloudy? My guest has an answer for all of that. The key is a marriage of software and sensors to compensate for the unique conditions of the site combined with the hardware. Now that was something I could relate to. A tracker is by definition a mechanical moving part on a site that needs to have as little operations and maintenance as possible. It's a critical piece of the facility, yet must be entirely invisible. One of the features my guest boasts is the fact that their equipment has the fewest components of its competitors. For solar energy, which is trying to squeeze as much energy out of every acre, it's critical that these trackers give developers an angle advantage. My guest today is John Sharp, Vice President of Strategic Marketing for Array Technologies, a solar tracking developer based in Albuquerque, New Mexico. What may be surprising is that Array has been building trackers since 1989, long before commercial solar had the boom it's now in. Like many of you, I was surprised just how complex a tilting solar panel could be. John and I had a great time talking about all the scenarios where you'd want the tracker to do something other than stare at the sun. I hope you enjoy my conversation with John Sharp. We're here with John Sharp, Vice President of Strategic Product Marketing for Array Technologies. And John, are we seeing more solar tracking systems on solar farms these days?
Yeah, Jay, we are seeing an increased adoption of tracking systems these days. If you look back at industry data and industry predictions 21 through 25, we expect something like 60% fixed tilt systems and 40% tracking systems. That's going to equate to about 300 gigawatts of power plants with trackers. And importantly, what we've seen as recently as 2018, globally, trackers accounted for about 24% of the overall utility scale or large scale product market. The data from 2021 is predicting that trackers are going to move up to about 37% of that overall market. So we're definitely seeing a global growth in trackers. In the United States alone, we're seeing well over 80% of large ground mounted systems going to tracking systems for these power plants. And I think really importantly, two very large potential markets, India and China, have started to adopt trackers where traditionally they've been fixed tilt markets.
Right. And how much expense does a tracking system add versus fixed tilt? And what really factors into the decision to use tracking? For instance, if you're in higher latitudes, would it matter more if you did that?
Yeah, great question. So let me start with just a couple of the reasons that trackers are gaining market share, and then I'll talk about the costs and some specifics. With trackers, you get more energy yield out of a given piece of land than you do with a fixed tilt. I think trackers are being adopted more widely. In particular, we've got really demonstrated reliability and bankability of these tracking systems as the time in the field increases. Tracking companies, including Array Technologies, we've seen continued improvements on ease of installation, which lowers the install cost. We've seen continued cost structure improvements as innovation comes online with tracking companies, and all this leads to lower levelized cost of energy. In terms of costs right now, a tracker plus or minus adds 10 or 11% to the capital cost of a power plant that's using trackers as opposed to a power plant that's using a fixed tilt system. I went back to a couple industry reports in 2018. A fixed tilt system system was about 54% of the cost of a tracker. And as recently as last year, that gap has closed. It's about 63% of the cost of a tracker. So we're actually seeing tracker costs coming down faster than we're seeing fixed tilt structures coming down. And the energy yield difference is increasingly favoring the use of trackers due to smart tracking technologies and other ways to squeeze a little bit more energy out of a tracking system.
And how much more energy does a tracker usually yield? I know it's different where you are.
Good question. It does depend on where you are, but generally a tracking system will deliver about 25 or up to 25% more energy than a fixed tilt system. If you take a look at where and why you want to track the sunnier location you have, the more benefit you get from pointing directly at the sun. Even though they're a little bit more costly than a fixed tilt system, they do certainly offset that cost differential.
Look, I think if that feels like a good deal, you get about 25% more power, it adds only 10% more cost. But I've spoken to solar installers in the past about financing these projects, and one guest in particular, this was Radiant Reed, episode 84, was telling me how typical financial institutions, banks, for instance, still see solar farms as risky, being able to recoup their costs, maybe from the developers who are developing it. Do tracking systems have challenges getting financed on top of the solar farms? And I guess what I mean by that is there's data probably to support that they generate more energy, but you're asking for that much more capital on these projects, right?
Yeah. So first and foremost, I think the data actually supports the opposite conclusion that trackers are difficult to finance, at least for large power plants. We're seeing an increase in the usage of tracking systems on these large utility scale power plants. And in the United States alone, depending upon which market data you're looking at, you're expecting something between 20 and 30 gigawatts of trackers per year for the next 5 years. And that represents something on the order of $100 billion investment in power plant infrastructure that includes trackers. In terms of being difficult to finance, the data is pointing the other direction. And I think there's a couple good reasons for that, maybe a host of reasons. The first is, what are the risks? Obviously, you want to lower the risk and financing cost in procuring these power plant components. One way to do that is to go to bankable entities. We've seen renewable companies, including Array Technologies, that have really proven to be bankable over the years, and investors are aware of that as we see these long run times in the field. Array's been designing and deploying trackers for the better part of over 30 years. Some of the other things that may be a little bit less obvious, in my opinion, as you look at a solar power plant and trackers, there's not any risk of fluctuating fuel prices, regardless of what the source of that fuel is. If it wasn't solar, the sun's going to be there regardless of geopolitical issues or other issues that cause fluctuating O&M prices. And with a solar power plant, these O&M costs are fairly low and they're predictable and manageable. So I think getting the financing on those is more about how can you guarantee that you'll get your return on investment. And there's something else here, Jay, that I think is really important to talk about as we talk about power plant risks. One of the things that may not be obvious is that tracking systems, and in particular Array's tracker, we can actually use that tracker algorithm and that tracker functionality to mitigate risks associated with environmental hazards like hail and wind and snow, because we can move and turn the tracker into a position that will offset or reduce the risk of those events having any problems in the field. We're actually out there actively educating the market on how to mitigate those risks, working with insurance firms and third parties. And I really expect as the market matures and the financial markets mature, that we'll see an increased level of this understanding. We continue to preach reliability and lowest cost of ownership, not just lowest price, which can lower that operating risk. If you have a reliable component from a bankable entity that you know is going to be working for the design life of your system that you're trying to provide financing for, then that risk becomes quite small. And I think we're also seeing some other bonuses, addition of newer technologies, maybe even addition of storage and emerging technologies to improve the capacity factor or how much energy you're going to collect and benefit from and get cash flows from are being put on these PV systems. You're seeing demand shifting, you're seeing grid frequency and voltage control things that bring value more than just kilowatt hours of electricity, and you can improve the value of these assets over time and reduce those financial risks. And then I'd say maybe the last thing, these solar power plants are designed for the appropriate risk categories that any power plant or other kind of structure would be. There's risk categories out there. Solar power plants are assigned risk categories, and those systems are designed to meet those categories right there. I believe that the market has spoken. These systems are being financed, and they're being financed at a very rapid rate.
Right. Yeah, that more than answered it. In fact, to maybe piggyback on that and also the discussion we had on the Radiant REIT episode, one of the things that they were contending was that a lot of traditional financial institutions still weren't financing that. Now, this was, an episode that was about 2.5 years ago. What is the latest? Are these solar plants being financed more? And I think the reason why I'm asking that is there's still a lot of solar developers out there that simply package a project, right? They don't build it. They do all the permitting, all the preliminary work, but then they sell that deal off and another developer develops it and ultimately may operate it or sell it to a utility. Right?
Yeah, I would say you see a mix. There are a class of developers out there that take the project from start to finish. They are long-term asset owners, so they'll do the preliminary development. They will hire the engineering, procurement, and construction firms and work directly with them to ensure that they're buying and installing quality equipment. Then they will own and operate that plant for the life of the plant, which is, 20 years, in some cases 30 years, and they'll take that start to finish, including sometimes financing or even self-financing that. We do see out there in the market, of course, some development that will start out. They might own the plant initially, or they might even flip the plant even before it's been constructed. And so you will see a model where there is some trading of assets that are out there for sure. But I think at the end of the day, somebody owns that plant, somebody financed that plant and is responsible for delivering the return on investment over that approximately 20 or 30 year period. So hopefully that answers your question a little bit there, Jay.
Yeah, are banks financing it?
Yeah, what we're seeing is lots of different institutions and funds and things like that. I'm not actually an expert on project finance, but there doesn't seem to be any lack of cash coming into these investments. And we're seeing very large institutional investors come in and multinational corporations and procuring or bringing their own financing for these projects.
Sure. These companies that do package up the projects, they don't necessarily build them. Let's just call them solar developers. When they package up these projects, do they already have, yes, we're going to add a tracker, no, we're not? Or is that decided in the construction phase?
Yeah, I would say that during the feasibility stage of development, when these developers and investors are looking at what kind of return they can get on a given investment for a power plant, generally they've already gone through the decision tree as to whether or not to add a tracker or not, and making sure that the energy output of a system in this case is going to meet the long-term need. And so, at least from my perspective, generally when a project starts to be developed, very soon in that cycle, you choose to be tracking or not tracking. And again, at least in the North American market, the vast majority of those plants, the decision to put tracking in place has already been made as the development cycle is kicking off.
Yeah, you mentioned that about 40% of the solar projects are going to have trackers on them.
That's globally. In the United States, for utility scale power plants, that number is well above 80%. And so the adoption of tracking technology in the United States has swamped fixed tilt for utility scale power plants.
Okay. Is there any connective tissue as far as which ones are using trackers and maybe which projects are not? I guess it'd be more interesting to know why projects would not be using trackers at this point.
Let me take you through the decision tree. We already mentioned that, yes, trackers do cost a little bit more. If you happen to have upfront capital limitations that can't be moved and you're trying to meet a certain energy output, not having enough capital upfront might drive you to choosing a fixed tilt structure. We also talked about energy versus cost. If you're trying to hit a certain energy target and meet a certain interconnection point per year or over the life of the system, and you don't have enough land to do that with a fixed tilt system, then you'll put a tracker on there to get more energy, as we already discussed. There are some cases where if you have, let's say, really high winds, the engineer of record may choose to put a fixed tilt structure in, because a fixed tilt structure in some cases can be anchored in more locations. And then lastly, if your site topography or the land is complicated enough in terms of having lots of ups and downs and very steep slopes, and the owner or designer might choose a fixed tilt system. But The things that I just described there, again, are fairly uncommon. And what we see is, again, about 80% or even much greater than 80% adoption of tracking technologies for the U.S. market, and about 20% of that being fixed tilt technologies for the U.S. market based upon those things I just mentioned.
Yeah, so let's get a little bit into Array. Tell us about your design. And I know there are a few companies out there with tracking design. So what sets yours apart?
So Array Technologies has been designing and installing trackers for over 30 years. And for a simple tagline, I would say that the guiding principles of our tracker and our company are engineered simplicity leading to long-term reliability. And the architecture that we have is something called a one module in portrait, or we have one module that faces in the east and the west direction in these long rows. We link many rows together, and we have a passive wind mitigation technique combined with a single bolt clamp that secures the module to the tracker. First and foremost, our architecture has the fewest number of components per megawatt or per unit of production. In some cases, we've seen over 190 times fewer components than some of the competition that's out there. Simplicity and fewer components, making it much easier to install. Our tracker actually has very good design flexibility. We can take our tracker and mold it to sites that don't have straight edges with wandering edges, and our tracker is actually quite good for highly sloped terrain as well. We have a unique scenario where we can put more modules in a row than most trackers can, and that increases the power density of the site. So if you have a land constraint and you're trying to get as much power on that site as possible, we actually have a really great power density, over 100 PV modules per row, that can increase the power output of your site. We've implemented a machine learning software so that we can get more energy production out of a given site, and we've deployed gigawatts of this now. We have zero scheduled maintenance. This is really important to your financial risks and your O&M costs, that there's no scheduled maintenance on our tracker. We have industrial grade components, maintenance free sealed gears and motors, and that can actually lead to something like 31 or more % lower O&M costs over the life of a plant. And we already mentioned this passive wind stow technique, but it's fully mechanical, and it's a way to handle wind in a very straightforward manner.
Right. And this reminds me a lot of when I worked in oil field. It was build it simple, build it tough, don't have a lot of extraneous parts, a lot of things that are hard to find. That just makes it a whole lot simpler, right? And that's interesting that you said you had multiples, fewer moving parts and components in there. I know that may not sound very sexy, but for solar operators, I'm sure that's a dream.
Absolutely. We try and make it simple to build, simple to install, simple to operate, and that creates that long-term reliability that then turns around and helps you guarantee that your asset will be functioning and giving you cash flows off of that performing asset over time.
John, one of the videos on your website described a passive wind mitigation system. What is that, and why is that important?
So a passive wind mitigation system simply describes the way that the Array tracker reacts to wind events and keeps the modules and the system safe. There's wind forces that are putting pressure on your modules and on your tracking system, and any structure that's out there in the wind has to be designed to withstand those wind forces. There's another issue with wind that relates to single axis trackers, and that these are long and fairly flexible rows, and that's oscillations that can happen at even low wind speeds. If you're not familiar with some of the oscillations that can happen to these long, thin structures, just look up the Tacoma Narrows Bridge as an example of one type of oscillation that can actually tear a structure apart. What most folks will do in the industry as they react to wind is measure the wind with an anemometer and then send that wind speed through a communication network to turn the tracker and go to a flatter position. A flatter position for a tracker, let's say 30 degrees, is a more stable position for a lot of trackers than either flat or something greater than 30 degrees. But you have to have all that communication working, all that equipment working, and make sure that that signal gets out there and go flat. So they'll stow at about 30 degrees, and when the wind event is over, then they can resume normal tracking, assuming there is no damage. We actually handle it significantly differently. Whereas that's called active stow, what we call passive wind mitigation works almost exactly opposite. We don't measure the wind. We don't really care how hard the wind is blowing. Our tracker is designed to handle the wind at any wind wind speed within the design wind speeds of the site. If there's an excess amount of force on any one of our rows, the wind pressure and the torque created by it will simply rotate that row up to its full tilt position, in this case 52 degrees. And at every foundation, we have a stop. Think of it like a door stop, where the force of the wind is transferred through that stop down into the foundation and down into the ground where it belongs.
Yeah, it might be kind of a silly question, but would there ever be a scenario where you would want to rotate on more than one axis?
I think the market has really spoken on this in the present. While we look at the additional energy that a single axis tracker like the Array tracker can provide over fixed tilt structures, a two axis tracker, for example, can and will provide more energy. However, the differences in the costs and the difference in the complexity and the operation and maintenance don't justify having those two axes working together to track the sun, both in its height and its trek across the sky. In this case, the amount of land that's generally required for a traditional two-axis tracker greatly increases, and the constraints around needing so much land and needing to run those wires and things over those distances really create a cross challenge. I will say this though, Jay, we don't know what the future will hold. We do expect innovation at Array, and the tracker segment in general is going to continue. This could include moving modules about more than one axis or about even a different axis. I'll never say never, but at least for the present, the market has spoken on that. Who knows what the future will hold, and we're going to be a part of that future innovation.
Maybe this might be a good time to take us through the components that are needed for a complete system. It's not just the hinges. How does your system know which angle to place each panel? Is it pre-programmed, or is there maybe a sensor out at the farm, the solar farm? And I also assume that probably they have a different tilt program throughout the year.
Yes, they're pre-programmed. And the answer to the second question, are there sensors that dictate some motion? Yes, as well. Most of the time, the movement of the tracker is pre-programmed to track the sun using industry-validated solar positioning algorithms that have been known for decades, and they're based on geographical location of the tracker itself. These are generally designed for power plants on flat land that are well installed and or perfectly installed, and they generally do a very good job of positioning the tracker to be pointing right at the sun when they're supposed to. However, there are two things I would say that offer opportunities to go off of that pre-programmed algorithm. If there's a non-ideal or non-flat site, maybe imperfectly installed trackers that are all supposed to be at the same height, but maybe one row is a few inches taller or shorter, these standard tracking algorithms may be less effective, in particular in the morning or the evening when the sun is on the horizon. There's a case, Jay, where one row can actually shade the row behind it. What the trackers will generally do is, instead of trying to point right at the sun when the sun's on the horizon or rising from the horizon, they will actually go to a flatter position to avoid the row in front of it shading the row in back of it. A new algorithm might be required, and we have a software package called SmartTrack that actually goes out and tests and looks for the optimal angle for that tracker, and will implement a new tracking algorithm to get more energy off of that site when the standard algorithms are less effective because of imperfect or highly sloped sites, something like that. The other thing that may be less obvious is we already talked about, hey, when do you want to track the sun? You want to track the sun in places where it's sunny and when the sun is out. But interestingly enough, when it gets very cloudy, and there's a lot of locations in, let's say, the upper Midwest or even the Northeast where you have a lot of time during the year where it's cloudy in a condition I call persistently cloudy. That means you can look up and you can't find the sun with your eyes. And there's a case where instead of pointing the tracker where the sun should be behind the clouds, it may be beneficial to go flatter where you actually see the whole sky or most of the sky. And SmartTrack does that as well. You asked, were there sensors that were involved? Every solar plant has something called a global horizontal irradiance sensor. It's easy to get the data. And you can take that information and make a decision. Hey, should I point where the sun should be behind the clouds, or should I go a little bit flatter and collect more energy? And we have that case in there.
You mentioned weather. In certain weather conditions, you might have the trackers just basically fold very flat. I'm wondering if you also would do that for things like when it snows.
That's a great question. question. Trackers are designed, any structure is designed to handle the wind loads that it would see in that certain condition in that site. It's designed to handle the snow loads. And obviously, if your tracker is fairly flat, then you're prone to things like hail and you may be prone to things like snow. And if your tracker is standing more straight up, or what we call full tilt, then the loads from the snow are reduced and the chances of hail impacting that module and causing damage are reduced. There are conditions around snow and hail where you may want to turn your tracker up to full tilt in order to reduce those loads or reduce the chances of impact of a hailstone.
Full tilt is straight up and down.
That's correct. And actually, most trackers, including ours, don't go to 90 degrees, but they will go to 50 or 60 degrees. The DuraTrack HZ V3 actually goes to 52 degrees, but most trackers either will tilt full tilt at something like 45, 50, or 60 degrees are the general ranges that you see out there in the market.
Let's talk about retrofits. Do you see a lot of retrofits on the existing solar farms? Are solar farms old enough to even be considering that at this point?
We're not actually seeing a lot of tracker retrofits. A lot of these utility scale power plants that incorporate solar and trackers are less than 5 years old. We've got systems, again, that have been around for decades, but the bulk or the majority of the systems have been in the last 5 years, of course.
Well, one of the things I was thinking is that you would convert to a tracking system if it wasn't already in place, right?
That's exactly right, or that certainly would be the opportunity. One of the things that we try to do, and we do with the V3 tracker, we attempt to future-proof the design. Module technology and sizes of modules have drastically changed over the last 10 years. A typical module, even 5 years ago, now is 50% bigger. What used to be about 2 square meters is now about 3 square meters. Mounting those modules can be a challenge if your tracker or your fixed tilt system has been designed for a specific size of module with holes in a specific location, etc. What we do with our tracker is we try and make it very flexible to accommodate different widths and lengths of modules and be able to, let's just say, move those modules around without having to completely redesign the entire system. And so a tracker from Array Technologies may have the opportunity to come back in and put a new generation of modules on the tracker and accommodate those differences in sizes and weights and widths and things along those lines. One thing we think about is what does happen if we retrofit. We did have a opportunity a couple years ago where there was an underperforming asset in Texas. We came in and worked with the developer and removed a tracking system that was not functioning properly. We're able to use the same foundations that were already in the ground, and then we retrofitted our tracker on top of that existing one. And because of the flexibility of our architecture to accommodate different modules and things like that, we were able to actually get that site back up and running.
Very cool. So what's next in solar tracking? Are we just trying to keep up with all the solar projects out there?
That's a great question. And I'm going to say there obviously is both. I can't say what's next, except that the solar market continues to surprise us, continues to grow faster than predictions, and continues to change on what seems to be about an every 6-month basis. The great news is the opportunity for solar seems to be essentially unlimited. The growth in the market has been phenomenal, and of course will continue to be phenomenal. What comes next? I think technologies that continue to drive out cost, that continue to be in sync with changes in the module world or the solar panel world, and find new and creative ways to get more energy out of the same piece of tracker equipment or the same piece of land or what's on the horizon. And I think we're just seeing the beginning of what we can do with tracking and solar technology.
Very cool. Gonna finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
Incredibly important piece of our energy mix. At some point, we will run out of it.
Crude oil.
Same thing. We're going to run out of crude oil. We need to be preparing for that moment. And I think the advent of electric cars are starting to move in that direction.
Nuclear.
It's been an incredibly important part of our energy mix up to this point. Countries like Germany are starting to phase it out because of the dangers associated with it.
Coal. And I'll add coal with carbon capture.
That sounds good. Unfortunately, what we see with coal is it doesn't seem to be economical anymore. And I hope that the good and hardworking folks from the coal industry are able to find employment in the energy revolution that's coming.
Wind.
Incredibly important piece of our energy mix. And of course, it's renewable, so it's here to stay.
Solar.
I think is the fastest growing segment in energy right now. Solar will continue to be the most important piece of energy generation growth that we see.
Biofuels.
Great opportunity to have the energy density that's required for things like vehicles and airplanes. And as long as they stay renewable, which they will, incredibly important mix for our transportation future.
Hydroelectric.
Yeah, I think in regions where you've got the resource, we need a mix of technologies, and hydro will be a part of that.
Geothermal.
Love geothermal because the best thing you can do with energy is not transform it from one form to the other. And all you're doing is taking heat and moving it from one place to the other. So very efficient.
Energy storage.
Makes all this possible with an energy mix, which comes online at different times. Energy storage will act as a capacitor to make sure we have energy at 24 hours a day.
Energy efficiency.
Comes for free. I like to say, turn out the lights, the party's over, but you also can just put in more efficient systems to get more out of the energy mix that's already out there.
And then finally, fusion power, nuclear fusion.
I remember something about cold fusion a few decades ago that didn't work out so well, but certainly there's promise there if it can be done safely.
All right, John Sharp, Array Technologies, thank you so much for your time.
Jay, I really appreciate you spending part of your day with me today, and thank you very much for your time.
That was John Sharp, Strategic Marketing Vice President for Array Technologies, a solar tracking company based in Albuquerque. I want to thank John for his time, as well as Lori Stern at Solebury Trout for setting this up. I last worked with Lori on my EOS Energy episode, number 121. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 135. Be sure to join us next week when we are introduced to a different solution for storing renewable energy, computing. Until then, I'm Jay Downhauer. We'll see you next time.